Yeah, good afternoon to all. The subject is green energy, and today's discussion we are going to discuss about nuclear fission and fusion. First of all, you should know what is nuclear reaction. So, nuclear reaction is going to release enormous amount of energy by altering the atomic nuclei. Okay, so if you take an atom, you will have electrons, protons, and neutrons. So with respect to your nuclear reaction, we will talk with respect to neutron. Okay, so a neutron is going to have an effect on radioactive material. Okay, so there are two types of nuclear reaction. One is called as nuclear fission and another one is called nuclear fusion. So in nuclear fission, it is a person is going to get divided. It is that we are clear from word fission, process where heavy atomic nuclear such as uranium 235 or plutonium 239, both are radioactive materials. They are going to split up into smaller nuclei, releasing an enormous amount of energy in the form of heat. So that is what we want. What we will do, we will get that heat energy, try to boil the water, make it as a steam, then the procedure remains same. That steam we will pass it across a turbine and you will connect a generator to the turbine, you generate power. Okay, so here we are going to tap the energy from the uranium 235. So here under nuclear fission, I am going to hit a uranium 235 with one neutron, so that will generate energy and uranium 235 will get divided into two lighter particles. Okay, on other side, nuclear fusion is the process where two light atomic nuclei such as hydrogen isotopes combine to form an heavier nuclei, releasing immense energy in the process. So this process also there in sun and star, where hydrogen they are getting combined to form helium. So starting with nuclear fusion, to start this process you need very high temperature and pressure. So extremely high temperature is required for hydrogen nuclei move faster enough to overcome electrostatic repulsion. So once that is happened with the help of high temperature and pressure, nuclear fission will start. Hydrogen nuclei collide and fuse to form helium nucleus and release energy. The mass difference between the reactants and the product is converted into energy, that is E is equal to mc square. We all know it is mass energy relationship. So you have dorium and thorium to form helium plus 4 neutron plus energy. Again this 4 neutrons will try to make that person into come in contact and they will try to get it as a chain process. So we can see here you have a dorium and thorium here, this two gets combined and try to form helium. Side by side I will get a neutron as well as energy. Key features: require extremely high temperature, produce more energy than fission, no long-lived radioactive waste. Whereas when you talk about there, you need uranium 235, which is a radioactive material. Here it doesn't require any radioactive material. No risk of runaway reaction. Application for nuclear fusion is potential future power source. Research is going on. So till now we are not using this process for generation of power. So hydrogen bombs use uncontrolled fusion reaction for explosion and is there in stars and sun. So our sun, we are able to get light and energy from our sun is by the process of fusion. So nuclear fusion working, first of all neutron bombardment, a neutron collide with the heavy nucleus, that is uranium 235. So here we need an uranium 235, but it is slightly risk, it is a radioactive material. Now once this neutron gets hit with uranium 235, nucleus absorb the neutron, become unstable and split into two smaller nuclei. So that is fission. In fusion, It is a combining process. In fission, it is splitting process. Energy release. A huge amount of energy is released when fission takes place. Neutron emission. Addition of free neutrons are released, which can initiate a chain reaction, whereas there that is not chain reaction, whereas here it is by nature itself it is a chain reaction. We can see here you have uranium 235. This uranium 235 is taken and you take a neutron and try to bombard it, you will get barium plus krypton plus again you get a 3 neutrons. So this 3 neutrons they will try to go on it again uranium 235. Okay, so what you have to do is we have to observe, that is you have 3 neutron is coming out, you try to observe 2 neutrons and 1 neutron alone is again left to hit uranium 235, so that it is a controllable chain reaction. So this is what you can see as a diagrammatic representation. You have uranium 235, a neutron hits this uranium, so automatically it becomes 23692. This is an unstable fellow. So since it is an unstable, it will try to divide it into 2. It will become boron and krypton, and you will have again 3 neutrons coming out of it plus energy. So you have to somehow you have to observe this 2 neutron, otherwise it will become uncontrollable chain reaction. Okay, so I am showing here. So 1 uranium is there. I am showing an example for uncontrolled chain reaction. So this will try to divide it into 2. Again you will have 3 neurons. This 3 neuron again it will go and eat 3 uranium 235. Again this 3 will become 6 and it will get gone multiplying, and thereby you cannot have a control. So you should have an arrangement for absorption of neutron. So if 1 neutron hits an uranium 235, you will get 3 neutrons. You have to observe 2 neutrons from it, and you are supposed to allow only 1 neutron further to continue the process. Okay, key features: produce a chain reaction, release gamma radiation and radioactive waste. So handling is little bit tedious when you go for power generation from fission reaction. Generated energy, that is harnessed in nuclear power plant to produce electricity. Application we all know, it is used to generate electricity. Then you have a nuclear weapon, then nuclear submarine and ships. Yeah, this is a very important role nowadays. Why we call it as submarines and ships? Because they are totally isolated. Ships or submarines will be not kept on land. It will be on sea. So I cannot use any other power plant method to generate. Whereas when you go for this nuclear power plant, it is very easy to construct inside the ship itself. So there are so many ships available in Indian Navy are all powered by nuclear fission reaction. Then nuclear power plant working. So nuclear power plant converts nuclear energy into electrical energy, we all know. And step 1, so step 1 should be nuclear fission reaction. You have to start your reaction. So what you will take, so inside the reactor core you will take uranium 235 or plutonium based upon the availability. Now in India we are going with thorium also, because it is abundantly available in India. So we doesn't want to stick on with other countries for getting permission or for getting the source. Okay, so you take any uranium, thorium or plutonium. Now you have to bombard 1 neutron on this radioactive material. This reaction produce heat energy and release more neutrons, sustain a controlled chain reaction you have to go. So we will observe the excess neutron. Second step is heat generation. We all know once this reaction takes place, huge amount of heat is being liberated. So this we will take it as for converting heat water into steam. Then that steam will be taken and it is being given to the turbine blades, and we will start to rotate turbine blade, thereby we will connect it to a generator. Step 3 is only electricity generation. This high pressure steam driven turbine which converts connected to a generator, that when the turbine starts to rotate, automatically generator prime mover will start, and thereby you will generate electricity. Then comes cooling and recycling. After passing through the turbine, steam is cooled using a condenser or converted back into water. So in some case I will leave the steam outside and again I will go for new water. but since it is a nuclear power plant, there is a chance for nuclear radiation in the entire setup, so we will go only for closed loop water. So automatically what we will do, we will go for cooling and then recycling, and then again use the same water for your power generation process. So this is the component of nuclear power plant. See, this is a box which is being shown is called as a nuclear reactor. Usually a several layer of brick structure will be used, and you will have a even more number of lead covers. Lead will be used as a sheet, because whatever there inside this is a radioactive. We are not supposed to expose. If you expose to human, then there is a chance for death. So inside that you can see we are using the fuel. This black like structure is your moderator, and the small dot which is your fuel rod. See the size of the fuel rod inside your Kalpakkam power plant, we all know it will be as small as in your needle, a safety pin needle. So that size is more than sufficient. So that is your fuel rod. Then I will have a moderator, then I will have a control rods. So this control rod, when you immerse, they will try to observe the excess neutron. So you will go on observing the excess neutron, and you will make the process to be in controlled condition. You will not allow it to uncontrolled. So now here heat is produced. This orange color, we can see it is an heat. So that heat I will try to bring it here, and that heat I am going to heat my water, and the water will get converted into steam. That steam is being brought into the steam turbine. After passing, again it will go to condenser. Again I will pump the water, and I will let inside the nuclear reactor. So what and all components we are seeing is a person called moderator, a person called fuel rod, then control rods, heat exchanger. From this heat, it is been transferred to water, so we call it as an heat exchanger. Then we will use three pumps. One is coolant pump, one is pump for pumping your back steam into your heat exchanger. Then after condenser, if I want for any external cooling towers, I will have a pump here. So here if you come to turbine, when you start to rotate your turbine, that is directly it will be connected to alternator, and alternator will generate power. So here I am just showing with an additional components which is used. This is what I have already told. This is your nuclear reactor. So outside the nuclear reactor you have a turbine. Turbine is directly connected to generator. Generator output is usually of high current, low voltage, but when you go for transmission, what we will do is we will step up. We will increase the voltage and reduce the current. Then you will have a electricity transmission line. So now you, after passing this steam turbine, steam is being brought out. You will have a condenser. You try to condense it, and further if you want to reduce the heat, I will have this structure is called as cooling tower. So where a cooling tower, against the gravity we will allow the water to flow, which means we will take this hot water to the top of this chimney. From there we will try to flow the water. So what happens is air flow in opposite direction. Air will move from bottom to top, whereas water will flow from top to bottom. So more contact you will get, and try to cool it faster rate. So when it is a sure 16 mark question, just if you draw this diagram, it is more than sufficient. You no need to draw with this setup. Even this is far better. So draw this diagram, and we have to, when you want to write, you have to write it as nuclear reactor. The heart of the nuclear reactor is nothing but fuel rod, control rod, moderator and coolant. Okay, then comes your steam generator. From this, it is common for all type of power generation using turbine. Okay, you will have a steam generator followed by a turbine, you will have a generator, then you will have a condenser and cooling tower. Okay, so control room is nothing but place where you will sit and monitor what is going on, whether it is under controlled condition, we will try to monitor. Okay, now one thing we have to move on is types of nuclear reactor used in power plant. So first one is pressured water reactor. So pressure water reactor is nothing but, you can see a pump here. This pump is revolving, so water is being sent to your reactor under pressured level. So I am going to increase the pressure. I will send the water, bring it out. From there, this is a water which will not come in contact with your turbine blades or generator. It is only within the reactor it will flow. Then that heat is being transferred to the water which is used here. So this water will get converted into steam. You can see here it is water, here it converted into steam, and that steam is being let into the turbine. Once this turbine rotates, automatically your generator will rotate and try to generate power. Again, this steam you will try to condense using a condenser. Again it will become water. That water is brought in. So this is the first type. Second type is boiling water reactor. The only difference is here we can see this path is different and this water is different. We are using this normal water here, and this is for heat transfer. So in the second, in boiling water reactor, what we will do, directly we will bring the water here, get the steam here, directly it will go to turbine. There won't be any intermediate heat transfer person. Okay, so that is the second one of boiling water reactor. And third one is slightly differences. Here with normally we use H2O. Instead of H2O, I can go for D2O, which we called as heavy water. So this will serve us as a two purpose. Heavy water will make the process to slow down, so you can use it as a moderator also. So that is we call it as pressurized heavy water reactor. So in heavy water reactor we will use D2O, and this D2O will try to reduce the process speed. So both for it serves as a for both purpose. And comes fast breeder reactor. In fast breeder reactor, use liquid sodium as a coolant instead of water. So here I will use liquid sodium. So instead of using water here, I will use liquid sodium. So produce more fuel than consumed by converting uranium-235 into plutonium. Example, this types of reactor only which will be used in India. And the last one is gas cooled reactor. So here, rather bringing this heat through any liquid medium, I am transferring the heat through air medium. So you can see here, till now what we have done is we have pumped water to the reactor, and then from water heat is being brought out. Rather I will use air as a medium. So air is being pumped here, so that air gets heated up, and that heat is being brought outside, and that heat is transferred from the air to water and make it as a steam. So usually water, the gas which we are going to use uses carbon dioxide. So thank you for patiently listening about